Hi everyone, this is Sarah in the CSS reverse engineering project within the Railsig, and this is my spring 2016 quarterly recap video. So the motivations for my project are very much coming from the fact that a lot of self-taught programmers these days are, one, using the web as a very readily accessible platform to get started with development, and two, rather than learning technologies in a very systematic fashion where they begin with, say, HTML or CSS fundamentals and progressively work their way up, a lot of self-taught programmers are increasingly taking an ad hoc approach where they will work on certain projects with predetermined outcomes in mind, oftentimes outcomes that are inspired by websites that they themselves have previously used, and then go about trying to implement these technologies, searching Stack Overflow, Google tutorials for whatever they need to implement that particular feature. And in this manner, they sort of develop their skills from the ground up in a very incremental and piecemeal fashion, as opposed to following like a very, well-defined arc of the content and the progression in which they learn new material. So the motivation here is that feature-rich websites built by professional web developers offer a lot of potential for learners to be able to reference them and use them as worked examples of particular techniques. But unfortunately, the code for a feature-rich professional website tends to be very difficult to navigate, which we'll see in a moment. And so the research questions that I focused on this quarter were, given a professional website feature, how can we allow learners to interact with it in a way that meaningfully promotes their understanding of how it's implemented? And two, how might these forms of learning differ from the kinds of learning that people can get just from using pre-existing resources like Stack Overflow and author tutorials? And finally, I'm interested in how real-world examples have the potential to complement rather than replace existing author tutorials in order to promote deeper and more specific learning about front-end programming, and in particular modern features and techniques in development. So our need finding for the quarter was very limited because we'd spent pretty much the entire last 2 quarters working on need finding. But things we did discover in particular were that users persistently, when they lacked the technical background and vocabulary to articulate search queries in terms of the kinds of jargon that experienced web developers might use, they would do so by sort of using very vague terminology where they would describe sort of their intended outcome in terms of features. So an example is this particular Stack Overflow search query. How do I make wildcard here like this website? And you can see through the results that there's an abundance of requests for help where a user doesn't really know what the exact name for the technique they'd like to implement is. So they're using this word a lot to sort of refer to a particular reference, even because they're not sure how to define it in terms of more formal CSS terminology. And so the central premise behind our system is designed to do 2 things. The first thing it's designed to do is facilitate the inspection process, and the second thing it's trying to do is to crowdsource material from existing authored quote-unquote toy examples and dummy tutorials that will allow us to provide more clarity from those tutorials into the more complex nature of professional web source code. So here we have an example of a website that is, clearly designed by somebody who knows how to design a website. It's in Turkish, but that's sort of beyond the point for this particular example. And suppose we would like to implement this particular feature where they have this full page background image, content just below the fold, and it turns out that if we resize it, it also resizes accordingly with the viewport. And so we would like to, let's say we would like to be able to implement this feature. Oh no, snap target, no. So we could, oops, okay, well, no, maybe. All right, there we go. So we could go about using the inspector, and if we start trying to look at what's going on with this particular site, you can see that in the bottom right corner where they have the computed styles pane, there are a ton of styles going on. And it's sort of unclear what directly relates to the kind of technique we're trying to implement, which in this case is the sort of background image. We can use the sort of selection tool to try to figure out more about what's going on. But again, it's very difficult to figure out what CSS I actually want to pay attention to, and what CSS is sort of orthogonal to the feature, even though it's still a computed style of that particular property. So in this situation, something I might do is continue to sort of look through these nodes one at a time in order to understand which nodes are responsible for which behaviors, but this is sort of a time-consuming process and also doesn't really provide any better understanding beyond what the inspector is giving me. And as a learner who doesn't have very much background in CSS, this is generally going to be too much information for me to be able to infer any sort of meaningful organization of properties. And so we developed a tool that now allows users to use a more lightweight inspector view. The interface for that looks something like this, and it's pretty similar to the DevTools interaction model in terms of how you inspect. So I can sort of inspect these individual elements when I click. It will show me the this pane with all the computed styles. The first thing to notice is that our system categorizes computed properties into quote-unquote functional groups, which is to say that we have said that, oh, okay, all of these background image and border related properties belong to the category of visual CSS properties. And conversely, right, the properties such as bottom and position are positional in that they primarily affect an element's position in the overall document flow of a page. Likewise for the box model properties. And you can sort of show and hide these categories based on the nature of the task you're interested in and what you think might be more relevant. The second thing to note, obviously, is that there are these highlighted properties here, and that sort of gives you an idea of which of the CSS properties might be more relevant. So in this situation, I've already specified to the system that I would like to be able to see properties related to the full screen background image feature. You can sort of see if you click more that now I've selected this large background div, and here, right, there is a background image URL as well as this background position 50%, 0%, and a background repeat property as well as a background size cover property. And it turns out that these are actually the CSS properties that are responsible for the quote-unquote critical behaviors of this technique, which is an image that is anchored in the middle of the page, expands to cover it, and is responsively centered. So this helps us find the properties that are relevant to our reverse engineering task much more quickly than through the other inspector interface. And for users who are more comfortable using the native Chrome DevTools, we implemented the same highlighting functionality in the native DevTools. So for example, I could highlight this background image, and here in the computed styles pane, you can see that we have highlighted in green and in some cases bold if we're very sure that a property is relevant. Properties that we think are likely related to this particular feature. And you can sort of infer as you sort of click through nodes, if a node doesn't have a ton of highlighted matches, so this one doesn't really have very many, and none of them are particularly bold, it's likely to be less relevant to the feature of interest than in the case of the main div, which contains a number of bold properties that we think are quite relevant. The way this particular mechanism is implemented is that it takes in an input that looks something like this in the bottom left corner, just a list of URLs to tutorials that currently exist for particular properties. And so the one here is for CSS tooltip, for instance. And so what the system itself does is basically takes all of these properties and goes through and gets the information from each of these tutorial web pages and calculates the frequency with which certain CSS properties are mentioned in the overall, across all of the different tutorials. And this sort of resulting image down here with 3, where 3 denotes high likely of relevance, would be for the background size property, right? We would say, okay, then CSS properties with called background size, background attachment, background position are probably relevant. These with label 2 might be relevant, but are probably not as critical. And that's how we get the input for the other system, which shows us which properties are relevant in the context of a professional example that you navigate to on the internet yourself. And so we got the chance to do a pilot study with about 12 different users, all of whom had between 1 to 3 projects worth of CSS experience, with the exception of 3 users who served as our experts in order to understand how learners interacted with the tool differently from these experts. And across the board, we saw a couple of things. First was that it was relatively promising how individuals found our tool useful. They repeatedly said that it helped them navigate to the correct, helped them navigate within the CSS element view to the more relevant properties, and it definitely decreased the time it took for them to identify and implement the critical behaviors. Unfortunately, something that we commonly saw with users was that they had a lot of difficulty finding the nodes in the left half to begin with. And by the left half, I'm referring to this part here of the inspector, where they had trouble sort of identifying what were the structural components that made up a particular feature and how they might go about identifying which ones to inspect, which is sort of a precondition to being able to see any of these CSS properties on the right. And so that suggests that something we need to do in the future is to implement the same sort of prioritization mechanism over. One second, sorry. To implement the same sort of prioritization mechanism for nodes that are in the left half of the inspector. Because that is sort of what allows people who have less experience with CSS to be able to understand the structural makeup of a particular technique along with the styling properties themselves. And something else that was very commonly expressed throughout the study was that learners would frequently try to search for relevant nodes and properties based off of reading the class names. So for example, in the full-size footer reverse engineering task, they would search through the inspector down here looking for class names that said something like footer, for instance. And although this is a problem in the sense that many websites in production will use minified or obfuscated class names, which means that this isn't a 100% reliable metric. That does introduce some ideas about ways in which we could sort of apply these semantic names to nodes, elements, as well as combinations of CSS properties to try to provide a better mapping and mental model for learners in understanding which sorts of properties are useful and relevant to a particular feature and which ones are mostly orthogonal. And so overall, for the next quarter and subsequent iterations of the study, we would like to get more of the affordances that we've implemented for CSS also working for HTML, and then do another study that tests whether or not the combination of the two is able to significantly decrease the amount of time it takes users to understand and reverse engineer features. So yeah, thank you for watching.